Hello everyone and welcome to another MoTeC webinar. My name is Mark McCoy and I will be your host. Today's subject will be the second worksheet in the initial setup workbook, or the ref and sync worksheet. Now what this is based on the crank and cam sensor setup that we have for our engine. So if I move over to my M1 Tune software, I'm already online with this ECU. I assume you would have seen how to do that in our other webinars. We can see over on the right I've got some scrolling parameters. This is like a time graph based on the actual information coming into the ECU at the time. So I'm on my initial setup workbook and I'm on worksheet number 2, which is ref and sync. So starting off, the first parameter we need to be entering is what is the engine speed reference mode. Now for anyone who's used to using our ECUs and our ECU software, this is basically what we would have previously called the ref sync mode. So once I've highlighted on that, I've got a drop down menu of all the available ref sync modes in the M1 ECU. Currently this list is just what we've been working with up until now, but obviously in the future this will get extended to include other vehicles. On the right hand side of that you'll see there's also some fairly detailed help on to tell you what the tooth pattern is sort of like for the particular ref sync mode you're choosing. So in this case I'm using my engine, which is a 2 missing 4-stroke, which means I have multiple teeth on the crank sensor with a space where 2 teeth have been cut away, so to give us a reference point on the crankshaft. In this case I have a number of teeth on the crank that would have been 36. Now realistically there's 34 physical teeth, but what you actually have to enter is the number of evenly spaced teeth that would be there. So with some of the, say the BMW engines which have a 60-2, that number is 60, not 58. I know on some of the forums with the later LS engines they refer to the 60-2 as a 58 tooth wheel. In MoTeC terminology this would be a 60 tooth wheel with the right ref sync mode. Now we have changed the way our crank indexing position system works. This is now called engine speed reference offset. It was previously called crank index position in our earlier ECUs. It does basically the same job, but it has been modified slightly to make it a bit better for the new M1 series ECUs. Now if we look over to the right here, we have some help. Now anyone who's familiar with the earlier ECUs will remember for something like a multi-tooth ref sync system, we used to use the sync sensor first and then use the following active edge on the ref as an indication point to where top dead center was, and then our crank index position was the number of degrees from that reference tooth or the index tooth forward to top dead center compression number 1. One thing you'll notice with the M1 is it's now the other way around. It's actually the reference tooth that is preceding the sync tooth, but then it's the same calculation of we choose our index tooth and then it's how many degrees back to top dead center compression number 1 in the engine running direction. So that's the only real difference. Same here down the bottom with a missing tooth mode. We used to use say the synchronization sensor would be before the missing teeth, and then that was our reference point. We now actually have the sync sensor and we use the missing teeth that is before the sync sensor as our indexing point, and then again just how many degrees from that indexing point back to top dead center compression number 1 in the engine running direction. So a slight difference there, but not too difficult if you're familiar with our previous ECUs. The next 3 parameters, they're basically some referencing sort of numbers that we use to sort of tell the ECU what to ignore and what to take note of. Now these parameters, you can read about them if you want, but my advice is quite literally to leave the blank ratio, the wide pitch and the narrow pitch thresholds, just leave them as they are. These will probably be hidden in future versions, and more or less, if we don't tell you to change it for your particular F-Sync mode, just simply leave these numbers as they are. There is no need to change them. Engine speed reference minimum. What we're simply doing here is just giving the ECU an idea of, okay, what does it need to be concerned about as far as RPM is concerned. And what we're saying here is anything under 50 RPM, consider it as if it was 0. So it's more an indication as to what is a stalled engine. This might come into play if you are using some auto start type functions on some of the race cars, but 50 RPM is probably a reasonably good indication here, 50 to 100 RPM, something like that. So as I said, below that RPM, it's not considered any RPM at all, so it would be considered as if it was 0. So obviously you have to be a little bit careful here. You don't want to set the minimum RPM to be higher than, say, your cranking speed. So if your engine cranks at 200 RPM, you would never set this to 250 RPM because the engine simply would never start. As for physical inputs for where you're actually wiring this engine speed sensor to, we default this to universal digital 1. It may be different on different engine packages, but you'll notice if I move away from that, it is actually sort of highlighted in a slightly different color, and there's no drop down menu, so you're stuck with using whatever we decide for that one, so no need to change that at all. Another quite important parameter is the pull-up control. Previously on our ECUs, this was simply called the difference between a Hall sensor or a magnetic sensor. This simply turns off the internal 5-volt pull-up connection to the engine speed sensor input or the engine synchronization pin pull-up. So quite simply, if you have a magnetic sensor, you would have the pull-up control off. If you have a Hall sensor or an optical sensor, you need to turn that on. So same applies for both the reference and the synchronization inputs. The edge designation is again similar to how we had it in the previous ECUs. We have a example here of a magnetic sensor and the green line basically being 0 volts. We would be concerned about this falling edge here as it cuts across the 0 volt the cleanest. Obviously this rising edge here doesn't sort of actually cross the 0 volts, so we're not interested in. So if you have an oscilloscope capture or a ref sync capture or something like that, that is a falling edge. If we have a magnetic sensor and we swap the two wires around, we now turn it into a rising edge. So you have to have some ref sync capture or oscilloscope capture of a magnetic sensor to work out which edge is correct for the way you've wired it. It's very important. If you get this wrong, the engine is actually unlikely to start. For a Hall sensor, the edges are quite square from the rising to the falling, so realistically, as with our previous ECUs, you can probably choose either edge of a Hall sensor. Again, same for the engine speed and the engine synchronization. You need to set them both specific to how your engine is. With the threshold, what we are basically saying here is at what voltage level do we consider a switching point, or what is the ECU looking for. So if I use the example in the drawing over here, we can see our threshold is 0 volts as I mentioned previously. So as that signal crosses 0 volts, that's what the ECU is interested in when picking the exact point at which that tooth happened. On a Hall sensor, what we will see here is, because a Hall sensor works between generally 0 volt as a low and some other voltage, maybe 5 volts, maybe 3.8 volts depending on your sensor, we actually have to set this value to something higher. So if this was a Hall sensor, I would probably have that pin threshold set at about 2 volts or thereabouts. Moving on to hysteresis. Now, what this is saying is whenever we set a threshold, that's just 1 voltage. But what we actually want to do is we want to have a bit of warning as to when the signal is going to cross the threshold. So we give it what's called a hysteresis. So it's more or less creates a band around our threshold voltage that gives the ECU some indication of when the correct edge is about to happen. Now, if I press F1, I will get some extra help on this subject, and you can see over here hysteresis on a magnetic sensor is, above or below 0 volts, and it simply gives the ECU time to say at this point here we're getting ready to trigger. So we know that everything from a filtering point of view seems to be okay up until this point, and as it crosses the threshold, that's where the ECU considers that tooth to be, and that's the point that it uses as a tooth timing. Same on the Hall sensor. We can see in this case the green line is set at about 2.5 volts, and we have a hysteresis of about half a volt, so that's down at 2 volts. So it's got a bit of a band which you can work in and be prepared for when it actually needs to trigger. So these hysteresis settings need to be considered when you're choosing your sensor, because a Hall sensor, this voltage swing will be fairly constant through the rev range. With a magnetic sensor it won't be. Basically, as the engine speed increases with a magnetic sensor, the voltage amplitude will change. So if I remove the F1 help screen, we can see here for my magnetic Toyota engine with a magnetic crank and a magnetic cam sensor, I actually have a hysteresis setting per RPM, and this is roughly about 30% of what the maximum voltage of that sensor would be at those RPMs. There's a fair bit of room to move here, but you don't want to set this too high, because what that will do is that could filter out the RPM signal altogether. Dbounce in the previous ECUs has been called filter. This is basically a time-based filter. So what we're talking about here is any signal that's of smaller total time than, in this case, say 60 milliseconds, just simply ignore it. It's possibly noise induced by maybe the ignition system, so we want to ignore that. So again, on this parameter, if I press F1, there's a little bit more help, and it basically gives you a moving window that if the signal is shorter time-wise than that dbounce time, it will simply be ignored. So obviously you would expect that your dbounce needs to be set based on how wide time-wise your signal actually is. This example here with 60 microseconds and 40 microseconds down to 20 is probably a fairly good example for a modern engine with a 36-2 type crank setup. You have the same obviously for both the ref and the sync, so you have to sort of set them both up, but your files will have these values already filled out by us. If you need to modify them slightly, then you can do so at your own will. Just one other thing that appears on this page that it's not hugely relevant to the actual ref sync setup, but we've added it in here so that you don't forget to set it. This is the engine speed limit maximum, which basically says what is my maximum RPM limit. So it's been put on this page just more or less to make sure you don't forget it, because you've got to come into this page anyway. You might as well be sure you've set these things up. Okay. Just with some quick diagnostic help, what we've done here is we've added some scrolling time graphs to give you an indication of what the system is actually doing once you start to crank the engine. Another very important indicator here is the engine speed reference state. At the moment it's in red, which is stall. Stall simply means that the engine RPM or engine speed is below our reference minimum, our 50 RPM. If I go to crank this engine, there's going to be a couple of things that are going to change. Our engine speed reference state has gone through a couple of different states. Over on the right, we can now see that our engine speed voltage and also our engine synchronization voltage is moving around. I'll just pause this because I want to talk about it. Just remember that these screens here, they're basically an update based on how fast your laptop or your PC can refresh the screen. So you won't see everything exactly how it is. The screen simply can't update fast enough, but you want to see some movement on there. Like the engine speed is quite noticeable, the engine synchronization not quite as noticeable, but there's a lot less teeth. One thing I'm going to do is just give you a bit of an indication. If I click over here before the engine has started, you can see that our engine speed reference state is red on stall. Now if I move up a bit closer and then simply scroll through, I want you to notice that as the RPMs start, the engine speed reference state goes through a few different states. Now the first edge and the first period basically say that the ECU has noticed that something is happening on the crank. So what that will do is it's more or less saying I'm about to try and calculate RPM. It'll move through those first couple of steps quite quickly. The next one is search. Now search quite simply says it's trying to work out what the engine speed or engine reference sensor pattern is doing. So this is your crank pattern. It's searching to match incoming teeth with the reference and sync mode that we've specified at the beginning. Once it's found that pattern, in this case the 36-2, it will move to the next state, which is pattern lock. Pattern lock says that it completely understands the crankshaft pattern. Now this is not engine running state at the moment because we still have to recognize our engine synchronization or our cam sensor. Always remember that the crank sensor and the cam sensor work in unison to give the ECU its idea of exactly where the engine is in its cycle. So if we continue along, it will search for a little while and then it should go to cycle lock. Now cycle lock is the final state of the ref and sync sensor input system. What it's basically saying is cycle lock is the ECU completely understands where the engine is in its cycle. So that means it understands the combination of the 36-2 crank trigger and the single sync sensor. So if you get to this stage, it means all your setup is correct. So that's what you're looking for. Okay, thank you for watching this worksheet webinar. Again, as always, if you want to find these webinars or other webinars, you can go straight to YouTube or you can go to the MoTeC website and search for the webinars. Again, if you have any other questions on this that aren't answered in any other webinars, you can always join our MoTeC forum and ask your questions there. Thank you for watching. This has been part 2 of the initial setup. I hope you're up for watching the next few parts. Thank you.